In this video, we will practice evaluating limits using L'Hopital's rule, and I will show you how to apply L'Hopital's rule to graph problems, which the College Board loves to put on the AP exam. If you appreciate the content, please give it a like. Number 1. Evaluate the limit as x approaches infinity of x to the third power over e to the x over 2. As x approaches infinity, the numerator approaches infinity. It just gets bigger and bigger. Also in the denominator, as the exponent gets bigger and bigger, the denominator gets bigger and bigger. So this also approaches infinity. L'Hopital's rule says that if the numerator and the denominator are both approaching infinity, or if they were both approaching 0, we can take the derivative of the numerator and denominator without changing the value of the limit. The derivative of x to the third power is 3x squared. The memorized rule is the derivative of e to the u is e to the u times u prime because of the chain rule. So the derivative of e to the x over 2 will be e to the x over 2, but we have to multiply by the derivative of x over 2. I'm going to think of x over 2 as 1/2 x. So the derivative is 1/2. Sadly, as x approaches infinity, the numerator and denominator are still approaching infinity. So we have to keep going. By the way, every time you use L'Hopital's rule, you must first show that the numerator and denominator are both approaching infinity, or 0. So this part is mandatory, where you write arrow infinity, arrow infinity. Do not write this. This is improper notation, and you will lose the point. So instead, write it just like I'm demonstrating. Let us again take the derivative of the numerator and the denominator. The derivative of 3x squared is 6x. Let's bring down that 1/2. And the derivative of e to the x over 2 is e to the x over 2 times the derivative of 1/2 x, which is 1/2, just like before. Let's combine these. 1/2 times 1/2 is 1/4. But the numerator and denominator are still approaching infinity, so we have to do it again. The derivative of the numerator is 6. The derivative of the denominator is 1/4 times 1/2 e to the 1/2 x. Multiplying these together, that's 1/8. This time, the denominator approaches infinity, but the numerator is a constant. If the numerator stays constant while the denominator gets bigger and bigger and bigger, the overall value of the expression gets smaller and smaller and smaller, closer and closer to 0. So that's the limit. Now, we had to do L'Hopital's rule 3 times. So it will not surprise you that L'Hopital's rule was the long way for this problem. This is not what you should actually do. So don't forget about what we learned back in Unit 1. If you are finding the limit of f of x over g of x as x approaches infinity, if f of x and g of x are one of these 4 different types of functions, they are both going to be approaching infinity. But this acronym FEPL ranks the functions in order from faster growing to slower growing. So factorial, exponential, polynomial, logarithmic. Factorial is approaching infinity the fastest, and logarithmic is approaching infinity the slowest. And here are some examples. Looking back at number 1, yes, the numerator and denominator are both approaching infinity, but they are not approaching infinity at the same rate. X to the third power is a very small polynomial, and e to the 1/2 x power is an exponential function. According to our acronym FEPL, exponential functions approach infinity faster than polynomial functions. If the denominator is growing faster than the numerator, then the denominator is getting bigger and bigger and bigger compared to the numerator. So the overall value of the fraction is getting smaller and smaller, closer and closer to 0. So the limit is 0, and All this would be done in your head. You don't have to write down any work at all. You can just think it through and put 0. The moral of the story is just because you can use L'Hopital's rule doesn't mean you should. So don't forget about what we learned back in Unit 1. Okay, for number 2, we really do need L'Hopital's rule. So we need to rewrite this as a fraction. Let's drop the x down to the denominator and write it as x to the negative 1 power. Throughout this problem, remember that x to the negative 1 power is equal to 1 over x. So I'm going to go back and forth between these two forms interchangeably. In fact, right now, I just dropped this x to the denominator and wrote x to the negative 1 power. But I actually think I would rather write it as 1 over x to make it clear what happens next. As x approaches infinity, the denominator of this little fraction is getting bigger and bigger, while the numerator stays a 1. So the overall value of 1 over x gets smaller and smaller, closer and closer to 0. Now I just explained that 1 over x is approaching 0. So this numerator is approaching a value of sine 0. And the sine of 0 is 0. So the numerator and denominator are both approaching 0. That means we can use L'Hopital's rule. Make sure you show this. L'Hopital's rule says we can take the derivative of the numerator and the denominator without changing the limit. I'm switching 1 over x back to x to the negative 1 power because it's easier to see the derivative in this form. The derivative of sine is cosine, so we have cosine. But the inner function is 1 over x, which I'm going to think of as x to the negative 1 power for a moment, because then I have to multiply by the derivative of this, which would be negative x to the negative 2 power. Also, the derivative of the denominator will be negative x to the negative 2 power. Wait a minute, these two factors will cancel each other out. We have 1 in the numerator and 1 in the denominator. So we are left with the limit as x approaches infinity of cosine of 1 over x. I told you I was going to use these interchangeably, and there you go. As x approaches infinity, the denominator is getting bigger and bigger, so 1 over x is approaching 0. So this limit is approaching the cosine of 0. And we know the cosine of 0 is 1. It is probably better if we show this step. So, kabam! Number 3, let's find the limit as x approaches 0 of arcsine x over x. Obviously, the denominator is approaching 0, but if we plug in 0 for x, what is the arcsine of 0? Don't forget that arcsine has a range restriction. The output values can only be between negative pi over 2 and positive pi over 2. Keeping that in mind, you evaluate the arcsine of 0 by asking yourself the sine of what angle is equal to 0. Well, the sine of 0 is equal to 0, so that's the value of arcsine, which is what the numerator is approaching. Since the numerator and denominator are both approaching 0, which you must show like this, we are allowed to use L'Hopital's rule, which says we can take the derivative of the numerator and denominator without changing the value of the limit. So, the original limit will equal the limit as x approaches 0 of, here's a memorized rule, the derivative of arcsine x is equal to this expression. So taking the derivative of the numerator, I'm going to get all of this. Now I didn't leave myself a lot of space to take the derivative of the denominator because the derivative of x is just 1, which is something that we don't need to write. So the original limit is equivalent to this. So let's do direct substitution right now. Plugging in 0 for x, we have 1 over the square root of 1, which is 1. On number 4, if we do direct substitution and plug in 1 for x, we are left with the cosine of pi in the numerator, and the cosine of pi is -1. Plugging in -1 in the denominator, we get the natural log of 1, which is 0. -1 over 0, this limit does not exist. We just put DNE and move on. Here is the limit from a climactic moment in the Mean Girls movie, which Lindsay Lohan's character had to solve to win a competition. Pause the video and try to find this limit by yourself. Just for fun, I'll put a link to this clip in the description. Let's use direct substitution to see what we get in the numerator and the denominator. Plugging in 0 right here leaves the natural log of 1, which is 0. The sine of 0 is also 0, so the numerator is approaching 0. Plugging in 0 right here, we have the cosine of 0, which is 1, and 1 squared is still 1. But then we have 1 minus 1, which is 0. So the denominator is also approaching 0. Since the numerator and denominator are both approaching 0, we can use L'Hopital's rule, which says we can take the derivative of the numerator and the denominator without changing the value of the limit. By the way, make sure you show your arrow 0, arrow 0. This is mandatory. Here's a memorized rule for your flashcards. The derivative of natural log u is 1 over u times u prime. So here we have the natural log u. Our u is 1 minus x. So the derivative will be 1 over u, 1 over 1 minus x times u prime. Again, the u is 1 minus x. The derivative of this is -1 because there's like a -1 right here. So this is going to be times -1, which I'm going to put right here. Moving on, I am bringing down the negative sign from the middle, and the derivative of sine x is cosine x. Moving down to the denominator, the derivative of 1 is 0, so that's nothing, and I'm bringing down this negative sign. Students often mess up trying to take the derivative of a trig function with an exponent. The key is to understand that cosine squared x means cosine x whole thing squared. So we do have to use the chain rule. We have to take the derivative of the outer function, which is 2 parentheses. And then we have the inner function, which is cosine, and we have to multiply by the derivative of this inner function. The derivative of cosine is negative sine. So I'm going to write down the sine x part. The negative that I said is going to come to the front and turn this to a plus. Let's see what happens when we do direct substitution. Plugging in 0 for x right here makes this basically go away. So we have -1 over 1, which makes this term have a value of simply -1. Plugging in 0 right here, we have the cosine of 0, which is +1. So, in the numerator we have -1 minus 1. Therefore, the numerator is approaching -2. On the other hand, if you plug in 0 right here, the sine of 0 is 0, and that's going to wipe out whatever comes next. So the denominator is approaching 0. If the numerator is approaching a constant, while the denominator is approaching 0, the limit does not exist. Now I'm going to show you how to use L'Hopital's rule to find limits when given a variety of functions and derivatives, including the graph of j prime. This is a common type of problem for the AP exam. Use the information above to evaluate the following. Show clear supporting work. Number 1, find the limit as x approaches 0 of f over h. Direct substitution gives us f at 0 in the numerator and h at 0 in the denominator. So let's find f at 0. If we plug in 0 right here, we have the sine of 0, which is 0. 4 times 0 is 0. H at 0, we are given, is 0. So the numerator and denominator are both approaching 0. Showing arrow 0 is part of your clear supporting work, so make sure that you show it. Since the numerator and denominator are both approaching 0, we can use L'Hopital's rule, which says we can take the derivative of the numerator and the denominator without changing the limit. In other words, the original limit will equal the limit as x approaches 0 of f prime over h prime. Let's find f prime real quick. Bringing down the 4, the derivative of sine is cosine, but we have to do the chain rule. The inner function is x squared, and we have to multiply by the derivative of x squared, which is 2x. So putting this together, this is going to be 8x in the front. Let's see what direct substitution gives now. If we plug in 0 for x right here, then that's going to wipe everything out, and the numerator is approaching 0. But what is h prime at 0? That's another fact that we were given. H prime at 0 is 4. So the denominator is approaching 4. 0 over 4 is simply 0. So that is the limit. Number 2, the limit as x approaches 0 of g over j. So direct substitution, if we plug in 0 into g, that's going to just be 0. If we plug in 0 for j, well, that's a fact that we are given. J at 0 is 0. Arrow 0. Achievement unlocked. You may now use L'Hopital's rule. We can take the derivative of the numerator and the denominator without changing the limit. So we need g prime. This is a product, and I'm going to look at it as 4x times e to the x. So we will have to do the product rule to find g prime. For the product rule, you sort of go through it twice. The first time through, you take the derivative of the first factor, which is 4, and you leave the second factor unchanged. Then you put a plus, and the second time through, you leave the first factor unchanged, and you take the derivative of the second factor. The derivative of e to the x is still e to the x. So this is g prime. For the derivative of j, we're just going to leave that as j prime. We don't have an actual function for that. So let's see what we get if we do direct substitution with this 0. Plugging in 0 right here, e to the 0 power is 1. 1 times 4 is 4. Plugging in the 0 here wipes this term out. So the numerator is approaching 4. But what about j prime at 0? Well, here's the graph of j prime. J prime at 0 is just the value of j prime right here, which is 2. So the limit is 4 over 2, which is equal to 2. Looking back, I feel like we should show one more step. We are supposed to show clear supporting work. Let's show the part where we plug in the 0. Unless it's a multiple choice question, be sure to show your direct substitution. Here's what it looks like for number 2, and here's what it looks like for number 1. Number 3, let's find the limit as x approaches 0 of g over f. We have already established that direct substitution gives 0 for g and 0 for f. Just don't forget to write arrow 0 before you employ L'Hopital's rule, which says the limit as x approaches 0 of g prime over f prime will be equivalent to the original limit. We already found the value of g prime, which is right here, and f prime, which is right here. So I'm just going to copy these expressions down. Now let's evaluate this limit by direct substitution. Let's plug in 0 for all the x's. This 0 wipes out this term. E to the 0 power is 1, so we still have the 4. This 0 turns the entire denominator into 0. 4 over 0, this limit does not exist. So we can just put dne. By the way, you are not allowed to write an undefined expression or an indeterminate form in your work. That's why I never write 4 over 0. I write arrow 4, arrow 0, and go straight to dne. So just be sure to never write this in your work or something like this. Number 4, let's find the limit as x approaches 0 of f of x over j prime of x. Interesting. We have already established that f at 0 is equal to 0. But what about j prime at 0? We have the graph of j prime right here, and j prime at 0 is 2. It looks like we immediately have our answer. We don't need L'Hopital's rule. 0 over 2 is simply 0. Kabam! Hey guys, don't forget to like and subscribe, but also if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.